In this video, we will be talking about curves defined by parametric equations. So here are basically the two things, or the six things you need to know of this topic. So when you do curves by parametric equations, you have to know about line segments and you gotta know about the center. And I know this might look confusing at first because you don't even know what is going on, but I'm gonna show you that you need to know. But whatever you gotta do, take a screenshot of this, save it, because you're gonna need it for the next problems. Let's take a look at this problem. So it says sketch the curve by using the parametric equations to plot points. Indicate with an arrow the positive orientation of the curve. And as you can see here, you got two functions, right? You got the x function and your y function, and you got your values over right here. And these are like the endpoints, right? Because they are like in terms of t, right? So when you're giving these equations, there's always going to be like a t, right? And what you got to do with the t is you got to plug in all the numbers from -4 to 4, and you got to plug in those numbers to t for each function. So let's plug in all the values for -4 to 4. So I made this chart so it could be much easier. So when we do this, we got to put the -4 in the beginning and the +4 at the very end. So we have to find three other numbers that could be like have like equivalency to or with that are between -4 and 4. So we can go by +2, right? So we can go -4 plus 2 is -2, and +2 is 0, +2 is 2, and if you do 2 plus 2 it will be 4. So we got some numbers for t. Now we have to plug it into the function. Alright, so here are the functions for reference, and we could plug in each one by one. So we have to plug in each one into each category. So let's just do that. So I got all my values over here, and now I gotta plug them in into the chart. Alright, so now we gotta sketch a graph, and as you can see, I already did it. Now we gotta just use the values from the chart, and now we gotta plug them in. And when you're doing this, it doesn't have to be perfect, it just gotta get the job done. So we did our final thing. Now we gotta put in the arrow of indication. And in this case, it will be going like the the arrow that I'm doing, like, so it's going up basically because it goes from -4 to 4. So and when you plug in the -4 for t, it started at 18 and -16. So we're just gonna go all the way up here. And that's pretty much how you sketch the curve when doing parametric equations. All right, so let's look at this question. So this one is about line segments. It says find the parametric description of the line segment from the point P13 to the point Q -2, 6. Draw its graph and indicate the positive orientation. So as you can see, I put in my graph here already sketched out. And what we're gonna do here is different. So we gotta use the equation from the beginning that I showed you, right? So we got to use A, B, right? And C, D. So this is going to be important. So if you guys don't know what this is, basically just pretend when they ask you a question, right? They give you a point, right? So you got 2 points. You got 1 point, point P, and you got point Q, right? So basically these points, they're going to be substituted into these slots. So like, so point P13 is going to be AB. So I'm going to make it easier for you. So this is going to be 1, 3. A is gonna be equal to 1. B is gonna be equal to 3. And point Q is the other point. So that is CD. So this will be -2 and 6. So A will be, these points will be matched up to the points corresponded to, the question. So that's pretty much how you do A, B, C, D. And I'm gonna do the next step. So the next step, we also got to use the thing from the beginning, the equation from the beginning. So we got our equation xt equals to 1 minus t a plus ct, and we're gonna do that. So basically we gotta just gotta plug and chug at this point. So in this case for x, so we gotta plug in, we got a, right? And we got our c, right? We got our a, we got our c, so we can just plug and chug at this point. So it'll be 1 minus t, we don't have a t yet, so, and this will be 1, and it will be plus c, that will be -2t, and this will be equal to 1 minus t minus 2t. So this will be equal to 1 minus -3t. And we got to do the same thing with the y. So our y equation for this one is 1 minus t b plus dt, and we got b and d. So we just got to plug and chug. So this will be 1 minus t, our b is 3, and our d is 6t. So this will be equal to 3 minus 3t plus 6t, and that will be equal to 3 plus 6t. And our final step is just to like find our final answer. So this will be, the y will be equal to 3 plus 3t, and that's what you need to know. But we're not done yet because we gotta do our positive orientation. So basically we're just gonna plot in the points at this point. So we got 1, 3, right? So 1, 3, we could just do that. And -2, 6, so this would be -2, 6. That'll be like that. And we have to indicate the positive orientation. So our line segment is just going to go straight there. But our positive orientation, it's going to be where, so it's going to be from, the arrow is going to be pointing up because it's going from P here to the point P -2, 6. So that's pretty much all you need to know. So you got to do this, sketch this, and you got to do this. If you take a look at this, so this one is about circle and arcs. So it says give the center and radius and indicate the positive orientation. So as you can see, we got an x and a y functions, and we got from 0 to pi over 2. And we're going to do something very simple. So our first step is to just plug in the 0 and pi over 2 for t to get the x and y functions. As you can see here, I already did it, and it's pretty much you have to do 0 and pi over 2 because that's just how I do it simpler way. You can do pi over 6, pi over 4, but for this situation, we can just do this like the quick method. So then our next step, it says give the center and radius, right? So from the beginning, I showed you the equation, and the equation was that x2 plus y2 is equal to cosine t plus sine t. And what I mean, what this means is basically we can just plug and chug, guys. Look, we got so we have x, right? And we can just put that into here, right? What I mean by this, so x2 will be equal to x, so x equal to 3 cosine t, but it has to be squared because it's like that, right? So, and then we got y squared, and that's y equals to 3 sine t, but we gotta square it too because it's y squared. Next, we gotta do our little equation step. So x2 plus y2 is equal to cosine square t plus 9 sine square t. And we can take out the 9 here. So we are left with cosine square t plus sine t. Remember from our trigonometric identities, cosine squared plus sine squared, cosine squared x and sine squared x is equal to 1. And we have t here for the t is replaced for the x, but it's the same thing. So this could be just equal to 1. And that's how you do it. So, and this is the circle equation. I don't know if you all remember it from pre-calc or something, or algebra 2, I think. And we know that the radius is going to be the square root of the number here. So our radius is going to be equal to 3, right? And the center, if there's nothing here, like the x2 plus y2, then it's going to be 0. But if you got like something else, then it's going to be another number. So in this situation, it's going to be 0. The center is going to be 0. So our radius is equal to 3 and our center is equal to 0. And that's how you do it. Oh yeah, and when you do this, this is going in the positive orientation, and the positive orientation is going to be a clockwise direction. And that's pretty much all you need to know for this question. So let's take a look at this question. So it says parametric equations of circles. Find the parametric equations for a circle centered at 2, -4, with radius 3 over 2, generated counterclockwise with initial point 7 over 2, -4, and given interval for the parameter values. So this might seem like a lot, guys, but it's not. Let's start off with the first step right off the bat. So we got to use our A and B here again, right? So our A for this one is the center, right? So it's -2. So it's 2, my bad. It is 2 and -4. So that's our AB, right? And our CD, the next point, and our CD is the next point. So that's going to be 7 over 2 and -4. So boom, we're done with that. So now let's go to the next step. And from the equations from the beginning, E equals A plus R cosine T, Y T equals B plus R sine T. We're basically gonna plug and chug again. We're gonna plug and chug. So basically we're gonna plug it. So this is gonna be 2 plus R, and R is the radius, and they give us the radius right here. So R plus 2 plus 3 over 2 cosine T, and this would be B, so this would be -4 plus 3 over 2 sine T. So we're done with that, but we gotta do our next step. And we're going to use this for the next step. So we have to find the parametric equation, right? And what that means, we have to find the parametric equations, circle centered at 2, -4. So what that means, guys, is basically for t, right? You are basically plugging in t equals to 0. That's basically it. So let me just show you. So we're going to plug in t for 0, right? And we're basically plugging in chugging again. So let's take our equation from the first step and plug in 0. And that's going to be equal to cosine 0 is going to be 1. So this will be just 2 plus 3 over 2. And 2 plus 3 over 2 is equal to 7 over 2. And we got to do the same thing for the y function. So this is going to be -4 plus 3 over 2 sine 0. And sine 0 is 0. So this is going to be just -4. And the initial point for this is 7 over 2 to -4. And that's what we got from the beginning. That's what it says from the beginning question. The initial point, 702 -4. Give an interval for the parameter values. So basically, we just got to show our work here. And that's how you do it when you're given a question like this. Thank you for watching, and I hope you enjoyed this video. Hope you got something out of it, and I'm going to see you on the next one.